Hello and welcome to the session. In this session, we are going to discuss the following question, and the question says that solve the given linear programming problem, maximize z equal to 12x1 plus 20x2 subject to minus x1 plus x2 is greater than equal to 13, 2x1 plus 9x2 is less than equal to 72, x1 is greater than equal to 0 and x2 is greater than equal to 0. We have to solve the problem, maximize z equal to 12x1 plus 20x2 subject to minus x1 plus x2 greater than equal to 13, 2x1 plus 9x2 is less than equal to 72, x1 is greater than equal to 0 and x2 is greater than equal to 0. Here we have mixed constraints. So here our first step will be to change the greater than equal to constraint into less than equal to form by multiplying the constraint with negative sign. So here we have the given constraint as minus x1 plus x2 is greater than equal to 13. On multiplying it with the negative sign, we get x1 minus x2 is less than equal to minus 13. So we have maximize z equal to 12x1 plus 20x2 subject to x1 minus x2 is less than equal to minus 13, 2x1 plus 9x2 is less than equal to 72, x1 is greater than equal to 0 and x2 is greater than equal to 0. Now our next step will be to add slack variables to the constraints to change in equal to form and form the initial simplex table. So we get maximize z equal to 12x1 plus 20x2 subject to x1 minus x2 plus s1 is equal to minus 13, 2x1 plus 9x2 plus s2 is equal to 72, x1 is greater than equal to 0, x2 is greater than equal to 0, s1 is greater than equal to 0 and s2 is greater than equal to 0, where s1 and s2 are slack variables. So we have the following equations: x1 minus x2 plus s1 is equal to minus 13, 2x1 plus 9x2 plus s2 is equal to 72, minus 12x1 minus 20x2 plus z is equal to 0. Now we have to choose the pivot element. This is our initial simplex table. Now see, here we have a negative number in the rightmost column, that is the RHS column. So we will first deal with the negative numbers in the last column irrespective of having negative values in the bottom row. we move towards left in that row. Here we have a negative number -1. So this x2 column is our pivot column. So it will be the incoming basic variable. Now to choose the pivot element, we find the ratio by dividing the elements of the rightmost column by the corresponding elements of the pivot column, leaving the last row entry. Now that we have to choose only positive ratio, here we have -13 upon -1 equal to 13 and 72 upon 9 equal to 8. So minimum of 13 and 8 is 8. So 9 is the pivot element and S2 is the outgoing variable. Our next step will be make this pivot element 1 and all other elements in the pivot column 0 using row operations. To make pivot element 1, we divide the whole pivot row by 9. So we get 2 by 9, 1, 0, 1 by 9, 0 and 8. So we have the following table. See, x2 has entered the basic variables. Now we make -1 and -20 in the pivot column equal to 0. For this, we use operations R1 equal to R1 plus R2 and R3 equal to R3 plus 20 R2. So now we get the following table. Now we again check for the negative values in the rightmost column. See here, we again have a negative entry in the rightmost column. So again we follow step 3. We move in the row corresponding to -5. Here we are not having any negative value. So we are unable to choose the pivot element. So we cannot proceed further and are unable to find a feasible solution. When a simplex table has a negative entry in the last column and no other entry in the row are negative, then there is no feasible solution. So the given linear programming problem has no feasible solution. Also, if we see the graph of this linear programming problem, there is no region bounded by the constraints -x1 plus x2 greater than equal to 13, 2x1 plus 9x2 is less than equal to 72, x1 greater than equal to 0, x2 greater than equal to 0. See, x1 is greater than equal to 0 and x2 is greater than equal to 0 show that the feasible solution should lie only in the first quadrant, and there is no region lying in the first quadrant which is common to both -x1 plus x2 greater than equal to 13, 2x1 plus 9x2 less than equal to 72. So there is no feasible region. This is the required answer. This completes our session. Hope you enjoyed this session.